Precalculus 4.6 Day 2 notes. We're going to be looking at the graphs of cosecant and secant, which are reciprocal functions of sine. And so to do this, we are going to start by graphing two periods of sine and just dot that. And then the zeros of sine will be where we get asymptotes on cosecant. So the zeros of sine are going to be where we get our vertical asymptotes on cosecant, because that's where we get the reciprocal, and dividing by zero is undefined. And so we're going to go for two periods. And so I'm going to go up to 1 here and down to -1. I'm going to let two boxes be 1 on the y. And the key increment on sine is pi halves. And so that's one period. And if we go 4 more key increments, which would be another full rotation, we'd be at 4 pi. And so sine starts at 0, goes up to 1, goes to 0, down to -1, 0, and then repeats. And I'm just going to dash. Again, this would be a no calculator activity. So there we have sine for two periods. To 2 pi is 1 period, to 4 pi is 2. And the asymptotes on the cosecant are where sine is 0, because you get the reciprocal, you get 0 in the denominator, and so we are going to have vertical asymptotes every place we have 0 on sine. So we have a vertical asymptote here, and a vertical asymptote here, 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 and here. And so sine goes from 0 to 1 between 0 and pi. And when you take y values, like say we're on the unit circle, quadrant 1, and we take where this is a pi 6 reference angle, then on the unit circle, this is to the right root 3 over 2 and up 1/2. Well, cosecant's the reciprocal of sine. So the cosecant of pi 6 is going to be 1 over the y coordinate, and it's going to be 2. And that's what happens all the way as we go through that first quadrant, is when you do the reciprocal of values between 0 and 1, you get values that are larger than 1. And the one place where they're the same is when sine is 1. And so the graph of cosecant has the same points when sine's 1 or when sine is -1, so they're going to share those points. But other than that, when you do the reciprocal of something that's between 0 and 1, you get something larger than 1. And what happens is, as the values get closer to 0 on sine and you do the reciprocal, the values on cosecant go to infinity. And so that's how we're going to graph this. Right now, I only have half of a period of cosecant. The period of cosecant is 2 pi, just like it is for sine. The other part is sine's negative in quadrants 3 and 4, so the cosecant's negative. And when I do the reciprocal, then what happens is I get where these are going to negative infinity. So right now, from 0 to 2 pi, I have one full period of cosecant graphed. And then we're just going to repeat this pattern for a second period. And so the x-intercepts of sine are my vertical asymptotes. So I'm going to have asymptotes. You need to be able to give me the equations of those for the periods that you graphed them at is an x equals 0, x equals pi, x equals 3 pi, and x equals 4 pi. And those are my vertical asymptotes. So there's one graph of cosecant. We do the same kind of thing when we get to cosine, secant. Secant is the reciprocal of cosine. And so we are going to sketch cosine. And so for cosine, we have key increments of pi halves again. So the 2 pi will be one period of cosine. We're going to graph the cosine. And 4 pi is going to be 2 periods of cosine. And so for cosine, it starts up at 1. So it's here, it goes to 0 at one of its key increments, and then it'll be at -1, then 0, and back to -1. So there is 1 period of cosine. And then we continue that pattern, going by key increments. And that's how you're going to graph the graph of secant. Again, secant is 1 over cosine of x. And so the zeros of cosine are going to be where we get vertical asymptotes. So for secant, so right here at pi halves, 3 pi halves, and another 5 pi halves, 7 pi halves, those are all going to be vertical asymptotes. And where cosine is 1, they will share a point. So they will share the point at 1 and at -1. So those will be points that they have in common because the reciprocal of 1 is 1. The reciprocal of -1 is -1. But just like in sine, as cosine gets closer to 0, say like 1/100th, the reciprocal of that is 100. Secant's going to be going to positive infinity. So secant's going to be following this vertical asymptote, getting closer and closer, but never crossing it. And then between pi halves and 3 pi halves, it's going to be just scooped down, and it goes and follows those vertical asymptotes. And when I get to 2 pi, if I stopped right there, I'd have one full period of secant. It's kind of awkward. We're stopping kind of in the middle, halfway in between the asymptotes, but that is one period. Then if I continue to draw a second period, try to make it look curved. That's not my best effort there. Kind of looks a little bit like a parabola in a sense. And there is 2 periods of secant. And the asymptotes are x equals, and they need to be equations of vertical lines, so you need x equals pi units away from that, 3 pi halves, x equals 5 pi halves, and then x equals 7 pi halves, and we have all 4 of those. And I think above I forgot x equals 2 pi. Oops, that was not good for cosecant. All right, so anyways, that's how we want you to graph those. So you've got those asymptotes are where the zeros were for cosine. All right, then we are still having phase shift and vertical stretches. We can have reflections in the x-axis. horizontal translations up and down. And so to graph y equals 2 secant of this, where it has a phase shift and a vertical stretch and a shift up or down, I'm only going to ask for just one period. And what we're going to do to graph this is we are going to graph the cosine graph and use it to graph secant, just like we did before. But there's a little bit of a twist to it because we have more going on. So in this case, my b value is 1. So my period is still going to be 2 pi. There's no change in period. So my period is 2 pi. And my key increment, again, is 1/4 of that period, which is pi halves. And then my phase shift is going to be going to the right pi halves, going to the right pi halves. And so the key increment and the phase shift already agree with the denominator, so we're going to go ahead and just grid this out by pi halves. And what I'm going to be doing is we are going to have to go up 1, but I'm going to save that for later. I'm going to go ahead and I am going to graph this before vertical shift. And the x-intercepts before the vertical shift will be our asymptotes. For secant. So basically graphing before phase shift means I'm graphing y is equal to 2 cosine x minus pi halves. So we'll start with that and then we're going to move it up. So let's take this little by little. And so we're at cosine and you have a vertical stretch of 2. The amplitude here is 2. And so cosine would start up at 2, and I've got to do the phase shift. So I'm just going to put an x there. And then cosine would go to 0. Then cosine would be -2 to 0, back up to 2. That would be before, that's just y equals 2 cosine x with no phase shift. But I need to go right 1/2. So if I go to the right 1/2, then let's see, I'll use green. If I go to the right 1/2, these are each going to scoot to the right 1 because my unit is going by pi halves and the phase shift is to go to the right 1/2. And so that is the graph of y equals 2 cosine x minus pi halves, where I scooted it to the right. And so where you have the zeros on this graph before your vertical shift, that is going to be where we have our asymptotes. So for one period, I am going to have a vertical asymptote at x equals pi, and I'm going to have a vertical asymptote at x equals 2 pi. Those are going to be my vertical asymptotes for secant. And then finally, I'm going to shift this cosine graph up 1. So let's use something else for that. Bright pink. So now cosine would be here, 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 and here. So I'm going to dot the cosine, dash it. And where we have our maximum. So for our 2 secant graph, my final graph of this, just deciding, I guess we'll do dark blue. Okay, where you hit the maximums, here and here, they're going to meet up. And then the secant is going to go up and go to positive infinity here. It's going to go up and go to positive infinity there. And where we have the minimum value on cosine, which is right here, the secant is going to open down and follow the asymptotes. So again, these are my equations of my vertical asymptotes for the period that I just graphed. So graph it without shifting up or down. You change the period. You look at the key increment with the phase shift and grid out. You get one graph of cosine that includes the period change and phase shift. And where that has zeros, those are going to be your vertical asymptotes, and then you follow by any shift up or down. All right, so that blue is my graph of my secant. All right, so now let's look at example 4, making it, kind of doing everything here. And what we're going to do is cosecant is the reciprocal of sine, so we're going to be graphing sine. And this has a b value other than 1, so I need to make use of structure. I need to rewrite this where I pull out the 2. And again, when I'm pulling out the 2, I'm really dividing each term by 2. And so I get x plus this pi force divided by 2, and pi force divided by 2 is pi fourths times 1/2, and I get a pi eighths. So this becomes x plus pi over 8. So dividing by 2 is the same as multiplying by 1/2. So here you have a reflection because it's negative in the x-axis. You have this amplitude's always positive 2, and the period on this is 2 pi divided by b, and b is 2. So the period on this is pi. And my key increment is always 1/4 of my period, so my key increment is pi fourths. And since I have a plus pi eighths in there, my phase shift is go left pi eighths. And then, of course, we're going to need to go down 2. But I'm going to figure out what my zeros are before I move down 2 to get my vertical asymptotes for cosecant. And then I want to think about how am I going to grid this out. So I'm going to look at my key increment and my phase shift and write them with common denominators. And since it's a pi eighths, I'm going to grid this out by pi eighths, and I have to remember that the key increment is 2 pi eighths. So I have a pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths, but because the key increment is going by 2, I'm only halfway through the period. I have 5 pi eighths, 6 pi eighths, 7 pi eighths, and 8 pi eighths, which is pi, which is my period. So that's where I'm going to get, and again, we're just going to go for one period on this when they get more complex. So I want to graph, I'm basically going to graph y equals -2 sine of the 2x plus pi eighths, and the zeros of this, before you move it up or down, will be where we have asymptotes. Oops, where? For the y equaling -2 cosecant. And so I'm going to think, okay, if I had sine, but it's -2 sine. Well, sine before I shift would be at 0. Then it would go to -2 at 1 key increment. But you have to remember the key increments are 2 pi eighths. But to make the phase shift easy, I went and marked by pi eighths. So sine in this case, instead of going up, it's going to go down to -2 with 2 pi eighths. Another 2 pi eighths, it'll be back at 0. Another 2 pi eighths, it'll be at +2. And then at its period, it'll be back to 0, 0. Or, back down to 0, I should say. But this is the graph before phase shift. So now I need to go ahead and do the phase shift and move this left pi eighths. So if I'm going to go left pi eighths, that's why I gridded it. Oops, I wanted to change this. There we go. I go left pi eighths. That's why I gridded it out with pi eighths, so that the phase shift is super clean and neat and precise. Go left, I just go left 1 unit for all of these. And that would be my sine graph with my phase shift and the reflection and the vertical stretch. And where I have zeros of those, I have vertical asymptote. So I have a vertical asymptote right here, a vertical asymptote here, and a vertical asymptote right here. So my asymptotes are going to be x equals negative pi eighths, x equals 3 pi eighths, and x is equal to 7 pi eighths for 1 period. And now I am going to apply the vertical shift. So if I apply that vertical shift, or it's going down 2 units, so for each of those green boxes, I'm going to go down 2. And my sine graph, which is not my end graph, so I'm just going to dot it, would look like this. And so the cosecant that we're going to graph is going to share the max and mins of the sine. So the cosecant graph is going to share where this is at -4 and where this is at 0. But it's going to then open down and follow those vertical asymptotes, never reaching them, just going to -infinity there, and then again, have it scooped up here. And there is 1 period of cosecant. Okay, so this is how you should do them. Don't pick up a Desmos or look at answers in the back of the book until after you've tried it all and worked it out. And there is a graph of cosecant.